This is part 1 of section 1.4, applications of linear equations in one variable. So we are continuing the word problems we did in the previous section. We're just learning new types, okay? This first problem, Luke Corey works at an ice cream shop. At the end of his shift, he counted the bills in his cash drawer and found 119 bills with a total value of $347. If all of the bills were ones and fives, how many of each denomination were in his cash drawer? Now remember, on the first read through, all we need to make sure that we understand is what we're being asked to do. So what did I get out of this? All right, we have some cash, some bills. They are all ones and fives. We know we have this many pieces of paper. We have this much dollars at the end of all of it. Okay, this is what I call a denomination problem. You use this anytime you have some sort of physical object that is worth a certain amount of money. Now, bills, of course, it could be coins, it could be tickets to a baseball game because you'll have a physical piece of paper that's worth a certain amount of money. Stamps, those kinds of things. One of the biggest things you need to make sure that you pay attention to is you have to make sure that your units match. Sometimes you'll be talking about coins, say a quarter, and you'll want to say it's worth 25, but it's worth 25 cents. But then in the rest of the problem, they give you how much it's worth in dollars. So you have to make sure that you're matching dollars and cents just you know, because you always have to make sure your units match for all problems. Okay, so let's go to this one. Okay, so I have ones and I have fives. I have 119 pieces of paper, and I know I end up with $347. One thing you can look at to kind of get an idea of what kind of answer you expect, if all I have are ones and fives, well, the amount of money I get from the fives is either going to end in a 5 or a 0, right? Okay, I end with a 7 here. Now, if the amount of fives I have gives me a value that ends in 5, I'm going to need 2 ones to get to this 7. If it ends in 0 with the number of fives, I'm going to need 7. So what I know here is the number of ones ends in 2 or 7. Now it could be 2, it could be 7, it could be 12, it could be 17. It just needs to end in 2 or 7 in order for this to make sense. This comes with practice. If you don't see this in the beginning, that's fine. It's just the more you practice, the more I point it out, hopefully, the more it will enter into your brain and make life easier for you. Okay, so you don't want to set this up with 2 variables because we don't know how to solve those yet. We'll learn that in a later chapter. Right now, we need to set it up with 1 variable. So I've read through, I kind of understand what's going on. I even have an idea of what to expect. Let's start organizing this information. I have ones and I have fives. I don't know how many of each, so let's just say I have X ones. I could have chosen X fives, that doesn't matter, okay? But I have a way now in math of talking about how many $1 bills I have. I need a way in math of talking about how many fives I have. That looks like fives, okay? What I do know is I had 119 to start off with. I don't know how many I've used. Let's just make it easy in our heads, okay? Let's say we had 100 $1 bills. If I had 100 ones, then I would have 19 fives, right? I would take the 119 and subtract away the 100 that I just made up and put right there to find out how many fives I do. The truth is, it doesn't matter what this number is. To find out how many fives I'm going to have, I always take 119 and subtract off the number of ones. Okay. Now, I have a way of talking about how many ones I have. I have a way of talking about how many fives I have. I need to deal with the amount of money now. Each of these is worth 1. I'm going to write the 1 in here, although you normally would not need to write that. That's how much money I get out of the $1 bills. Now, how much money do I get out of the 5s? Well, each of these is worth 5. So I take 5 and I multiply that by that number. And this needs to give me $347. Now I need to solve this. So I'm going to distribute the 5 here. I'm going to drop the 1 in front of the x. X plus 595 minus 5x is equal to 347. Now we have like terms here. X minus 5x is negative 4x plus 595 is equal to 347. Now let's subtract 595 from both sides. And I get negative 4x is equal to negative 248. I start to see negatives here and I start to get really concerned. Not worried, but just making sure that I really pay attention because I know a negative number won't make sense here. I can't have a negative number of $5 bills. Okay, so, but we're going to be okay here because when we divide by negative 4, our negative goes away and we end up with x is equal to 62. Okay, so what have I found? I found the number of 1s. We were asked how many of each denomination, so I need to find the number of 5s as well. But right here we also talked about the number of 1s needs to end in a 2, and it does. So I'm feeling pretty good about this. To find the number of 5s, I do 119 minus 62 to get 57. So our answer is we have 62 1s and 57 5s. We already said we couldn't get a negative number here. We also can't deal with fractions here because we can't have half of a $5 bill and have it count. All right, so we deal with whole numbers. We could not have numbers larger than 119 because that's the total number we have. This one's actually fairly easy to do a complete check on. We're good with money. You could figure out the value of this, find out you have 119, total value of 347, complete check, you're good.